Hello friends, welcome to today's session. So we will discuss some more numericals on the topic called as fluid statics. It's nothing but the static fluid, that is fluid at rest, is called as static fluid, and the study of the fluid in stationary or rest position is called as fluid statics. So the question before us is, so this is an important question and this is asked in GATE 2006. So it's quite challenging as well as interesting question, so have a look. The liquid surface in a cylindrical bucket of radius r rotating about its axis acquires a parabolic profile, which is given by the equation. So remember, this is the equation which is given as y equals a plus br square, where y is the height, y is height of the liquid from the bottom of the bucket at a radial distance r from the bucket axis. If the liquid has density rho, then the mass of the liquid in bucket is. So these are the four options given. So the approach of this question is, so now see the bucket, if we consider a bucket and they had been asking that it's cylindrical bucket and it's continuously rotating. So if the bucket is rotating and it's also filled up of some liquid. So if the liquid is filled in bucket and the bucket is rotating, so the liquid will not be stationary, so it will be continuously moving. So if liquid is moving, we will just show as it a vortex will be formed inside the bucket. So the vortex will form like this due to the continuous rotation of the bucket. So friends, here the height of bucket at every point will be different. So height at this point will be greater than this, here it will be different here. So at every point the height is different, so the height is continuously changing. So we have to take some value and then we have to just integrate to find out the total change. So you have to just consider a vertical strip here. A strip is need to be considered, and let the strip be of length dr. So see, now I will draw a top view to understand better. So if this is a bucket and if I consider a vertical strip, and if it is the bucket is rotating, so water inside it will form a vortex, and see if we consider a strip, it will cover the whole area. So if I integrated it with the radius as well as height, I will get the whole area of the bucket, or the you can say volume. And as we know, we are having with density rho and volume, we can just find mass, that is equal to density into volume. So I had considered this length of the strip as dr, a small strip of length dr, and let the height of the bucket be equals to y, because y is given as the height and a parabolic change or the equation is given. So we have to just find it as we have to just integrate the volume from 0 to radius r. From 0 we have to just integrate to radius r, we will get what? Volume. Okay friends, so we will start integrating. That is, we know that the volume of this bucket is equal to this circumference. I have to find the volume of the strip covering whole bucket, that is circumference of strip, which is 2 pi r, that is periphery, into, now circumference, I had got this whole area is covered. Now I just want to find that volume. So we know that volume is nothing but equal to area into length. Area, or we have just considering the strip, so we considered circumference into height. Height is nothing but y. So 2 pi r into y, and dr is the length of that strip. So we will just substitute the equations. 2 pi r, y is equal to a plus br square dr. Integrating on both sides, I get v equals to integration 2 pi r a plus br square dr. I will just remove all the constants out. 2 pi is constant, integration, and integration limits will be from 0 to capital R. 0 to capital R. R I will multiply with the bracket, so I get AR plus BR cube, then 2 pi. So integration of R is R square by 2 plus R cube is r raised to 4 by 4 equals, now limit is 0 to r. Substituting the limit 2 pi r square by 2 plus br raised to capital R raised to 4 upon 4 raised to 0 to r. So friend, we have got here volume. We know that mass is equal to density into volume. So volume I will just take forward. I will multiply it with density, that is pi rho. I multiplied the 2 with the brackets. I took out r square common. So I get, here something is missing. Oh yes, here a is missing. I will add a. So I will get a r will be taken out common upon 2 is cancelled with 2, so 1 plus br square. So r square is taken as common, so br square upon 2 is multiplied with bracket, so I will get 2. So I get an answer as pi rho r square a plus br square by 2. So where is that answer? Pi rho r square a plus br square by 2. So its correct option is option C. Observe this carefully. I will again tell you the approach, that we have just considered a bucket, we considered a strip, and we just integrated it with the circumference, so that we will get the whole area of the whole changing height. After that we found out the volume, and then we just use the formula mass is equal to density into volume, substitute the values and just go down. So we got the answer as option number 3.